All right, welcome back to the shop, and on today's video we are going to be using some of those oxy-acetylene cutting torch skills that we just picked up in the video before this, and we're going to make kind of like a free cycling creative project, yet something useful for the shop. So let's get started. All right, so before we get started, just a reminder that we are building off of previous video skills. So if you're going to pick up a cutting torch and try to duplicate something in this video, make sure you go back and you watch the how to safely set up and operate oxy-acetylene equipment, and also watch the safe setup and use of a cutting torch video. That way you know what you're doing when you pick up a torch. All right, so first off, if we are making a project video where we want to showcase a cutting torch, then there's got to be some specific reasons why we have picked that project. Now for me, there's two really big reasons that pop up. The first one would be that whenever you are making a metal project and you have to cut and shape and sculpt it out, if it's thin sheet metal, then you've got all these hand tools and equipment to let you do that. However, once it starts getting thicker than 1/8 of an inch, it starts to become really hard to do that, and a lot of those machines and tools you can't use anymore. However, if you got a cutting torch, then that makes really quite quick work of that, and you can do it no problem. Now, the other reason why I would use a torch is it gives you the option to be a little bit more creative. So you don't have to have this rigidly put against a fence and cut straight things. You can actually kind of use it like a pencil and just kind of freehand draw and cut shapes out. So you can do kind of like cut out silhouette art, or you can make kind of metal signs like this guy up here. And imagine something like this, really nicely well done and mounted to a big boulder with lights behind it in front of some rich dude's house, right? Really quite cool stuff. So the trick is trying to find a project where we can do both of those at the same time. All right, so I think I figured something out. So this is our tool room here. It's been here a long time, and somebody before me did a really good job of organizing this tool room. You can see we got all our sockets all organized nicely, got nice spots for our wrenches. However, one of the spots that I just absolutely hate, and every time I look at the board it bothers me, is my vice grips here. There's absolutely no clear identification of what's supposed to go there and where, or any kind of nice order of how they go in. Just these loose kind of pegboard stands. So that ends today. There's just some design aspects for this project. I kind of want to use this space here for this, and I'd like to have kind of maybe 4 or 5 of each type of vice grip. And since they all kind of have this standardized knob on the back, I thought that would be a really great way to have some way to hang these things. And then why not build in a nice sign telling everybody what goes there, you know, vice grips. Then we can have some creative use of the torch to make that too. Now, as for the sign that's going to say vice grips, you can totally just take a piece of soapstone and just write out and be a little creative and freehand it. But you can also kind of just use your computer and Word and make out a sign that you can use as a template. So we're going to do that. Then just mess around with your Microsoft Word and figure out a font that really looks cool and kind of represents what you want for your project. And you can always just change the scale, make it bigger or smaller, and then print it off and then go and check it on your project, and that way you got exactly what you want to make. Now, before we get too caught up in our project here and what we're making, we should decide what we're going to make this out of. Now, you can see this stuff right here. This is my sheet metal, and I pretty much only stock 20 gauge sheet metal. I do have some 16 gauge back there, but for both of these, they're kind of too thin for what I want to do. I want to make something kind of strong and skookum so it's not going to just bend when I hang it up on the wall and load it up with some vice grips. So this isn't going to work out. And then the next kind of choice up, I don't really carry a lot of plate steel, so I do have a piece of 1/4 inch thick plate steel. But really, for making a sign and a holder for a couple tools, this is a really kind of overkill kind of piece. So I'm gonna try to find something else and be a little more creative. All right, so like any good automotive or metalwork shop, you should always have a metal scrap bin. That way you kind of can store and hang on to things, and you never know when you're gonna need them or use them. So for us, you can see we've got like mufflers and old students' projects and frames and things like that. It's all useful, you just gotta find a use for it. So if we take a look in here and see if we can find some material that's more what we need. So I've got literally a car wheel dolly here that the dolly wheels broke off, and it looks like it is about 1/8 of an inch, so this actually might work for us. So we'll grab this out, take a look if there's anything else in here. That's kind of odds and sods in here. And what is this? So once again, here's something a little bit thinner. That's probably about the same, 1/8 of an inch. So this is going to be probably still overkill for what we're going to do, but at least I don't have to worry about anything getting all bent up and mangled when we hang heavy tools on it, and we can justify using our cutting torch for this project video. And then we kind of need something where we can kind of hang this inside of like a tube or a pipe or something like that. So where I'm looking at my material rack, you know, I've got some 2" by 2" tube. That would work. You could cut a groove in there, but that's going to be crazy honking big. So I do also have some 1" by 1". That actually might do the trick. And I usually have some shorter off ends in here that we could try and sizing this out. So I think that might work out for this. So this piece in particular, you know, I can take my cutouts here that I made and kind of see where I can space these out, and do I have enough clean material to be able to hack this out. Now this piece in particular has a whole bunch of little holes, but the beauty of working with steel is a quick little tack in there and a grinder, and you can't even tell that that was ever there. So that's not too much of a big deal, but these grooves maybe a little bit more. So I do have an option of trying to very carefully cut it out, but it's a little bit too small unless I decide to play with my font size. So let's take a look at the other piece now. Now looking at this broken wheel dolly piece, you know, it's got kind of some interesting shapes to it. So there's lots of sheet metal there, but it does have a big curve in it. But instead of looking at it from a negative point of view, maybe this is kind of cool. Maybe it's kind of already got that nice curved sign look to it, and we can just put our letters here, something like this. So that kind of looks pretty cool. The only thing I can see is it's kind of too big. The letter starts to come off here where it starts to flatten out. So if I print off something a little bit smaller font, then we can get that fitting in there, no problem. So I kind of like the look of that. So what I did is I reprinted this off at a slightly smaller scale, and it just happens to meet up right at the end and the beginning of that curve, so that really looks quite nice. And I was kind of thinking if I left this solid down here where this is connected to the letters and cut everything else above it, then you kind of have these 3D letters popping up and a nice little curve to them, so quite cool. Now that's the signage part of it. We got to still have some way of kind of figuring out how we're going to hold our vice grips. So we had talked about maybe cutting a channel in the tube here. This way these could slide in and being hung like that. So I want probably about 4 or 5 different types of vice grips and sizes. So we could do kind of some kind of pattern of these and lay them out so that there's enough space, so that there's no issues in them touching each other. And then we got a kind of cool thing in addition to the tool shop. All right, so before you grab a piece of steel and you start cutting up and making your project, it's always a good idea to know what you're dealing with. So for example, this piece here, do we know what this is? This could be aluminum, this could be stainless, could be steel. So one of the easy ways of figuring that out is you grab a magnet, and if it sticks to it, then it's got some iron in it, and this is steel. If it doesn't stick to it, then it's most likely aluminum, could be stainless. And if it's aluminum or stainless, you're gonna have a really tough time cutting it with a torch because it just doesn't work. Now the other issue with this piece that we picked up out of the scrap bin is that this has been painted, and we're not going to be doing any welding or anything like that without getting that paint off first, so we got to start tackling that issue too. In order to take this paint off so we can cut it and weld it and not have any issues, we kind of have a bunch of options, and I'm going to run through them real quick. Now option number 1 is get yourself some automotive paint stripper. Now this stuff is kind of a bit of an environmental disaster, but you're basically using chemicals to kind of just melt away that paint and dissolve it into nothing. It's kind of a little bit messy of a cleanup. You wipe it up and you got to kind of deal with it. It's all kind of like acidic, so you got to make sure that you don't get your hands dirty, etc. So there's a bit of cleanup. Make sure you have a well-ventilated area, but works pretty good. Another quick and dirty option for you is using a flap disc on a good old grinder. These little flap discs are basically just layers upon layers of sandpaper, and you can get them in different grits depending on what kind of surface finish you want. This one's a 40 grit, so it's going to be really quite aggressive, but we'll get the job done nice and quick, which is kind of what we want. So let's give this a try. Whew. All right, that's all cleaned up. In retrospect, that was a lot of work. So maybe you want to go with the paint stripper method, but just keep in mind, it's kind of messy, kind of an environmental disaster as well. So just pick your choice and get it all clean so we can start cutting and welding. So next up is transferring our stencil up to our project. However, there's a couple things we got to think about. Now, if I was to tape these down and use that as my template, as soon as I hit this with a cutting torch, it's just going to burst into flames and I'm going to lose my template. So that's not going to work. I'm going to find some way of transferring it to the steel. Now, the trick is doing it in such a way that I'm still going to be able to see those lines while I'm doing the cutting. Now, remember, I'm going to have to put on a green tinted face shield, so it's going to be a lot harder to see that line. So it's all about contrast. Depending on what the steel looks like, you need to mark it with something that has a really obvious difference. So, for example, if your piece has light rust on it or it's still got the original mill scale, a soapstone is going to be your best bet. You know, you can make a line on it, do whatever you need, and you're going to be able to see that really well because of the contrast between the colors. Now, because we've cleaned this up, this white chalk soapstone is not going to be all that legible against a shiny kind of gray metal surface. So in that case, you may want to switch up to something completely the other way, or like a Sharpie. So it's just a matter of trying, see what you can see best, and that's what you can use. In order to transfer these details over to the steel with the Sharpie, I've got a couple options here. So I could take a pair of scissors and very carefully cut out what I don't want here, and then use the Sharpie and trace around the letters and then get that for my template. However, there's a problem with that. I might be able to see the Sharpie, but if I burn it off accidentally because I'm getting too close to other letters, I'm not going to know where I'm supposed to cut. I'm going to lose track. So another little trick you can do is you can use a hammer and a center punch and just go over where your details, you know, maybe every ½ inch, you put a little slight center punch, get the main details like the corners of the letters and things like that, and then you can take your template off, go with your Sharpie and fill it in, basically connect the dots, and now you have your nice Sharpie mark, but if anything happens to it, you still have those center punch marks to look at, and those center punch marks are actually pretty easy to see with the green tinted face shield, so that helps that way too. So let's do that. Okay, well, that's all done. A lot of work. Was that kind of overkill? Maybe, but you know what? At least I'll have some peace of mind that if my Sharpie mark burns off while I'm cutting, I'll be able to see those center punch marks and still just continue on with my cut. This is all laid out and it looks exactly how I want it, so it's time to get suited up and go cut this out. not my finest work, so why don't we talk about what just happened there. So when I make these videos, I am trying very hard to do them as flawlessly as possible, but just like anyone else out there, I make mistakes. And it's important that as a good tradesperson, you are always learning and always improving and learning from your mistakes. So some of the stuff that just happened there, first one is, I even mentioned this before, if you're going to be cutting thin stuff, even up to 1/8 of an inch, a plasma cutter is going to do a way better job. So that would have been a better choice, but I am trying to show you guys using a cutting torch. Now the second thing is, I tried looking, I actually don't have a cutting tip that is for 1/8 inch, which would have been 000. I had to use my 0, and so what's happening is the flame is too hot, and there's too much oxygen, and so as I was making nice straight cuts, it was just constantly kind of re-welding itself back together. So what I had to do is I kind of had to adopt a new strategy where I would just do small little circles and blow them out and continue that way. So I was able to cut this out, but kind of had to tweak it a bit. So, that being said, this doesn't look that bad. You know, we picked a really cool piece from the scrap bin, and I'm really happy that now that I've cut the rest of the part off, it's actually still really quite rigid because of that 1/8 thick steel, and it's got a great shape to it. I'm thinking I'm going to take a grinder or a flap disc and kind of clean that surface up, take all the burrs and maybe some high-end spots off, but I'm going to leave all the edges and the flame cut. I think that's kind of got the appeal to the project. So, let's go do that. So now that I've got these pieces cut and deburred, the next thing I'm going to do is pick one side and cut a slot or a groove in here so that this knob can go in from the end and kind of slide down in there, and the head of the knob will kind of hold that in place. So I need the groove to be a little wider than this threaded section, that way this can go in and out, yet not so wide that the head of this wants to kind of fall in and drop the vice grip. So that's what we're dealing with. After really roughly laying this out on a piece to see what we got to do, you can see I've got two very long straight cuts, and so those are going to benefit greatly from using a guide. And then I don't have to go all the way through. If I leave the end here solid together, that'll kind of hold the shape a bit better at the very back end, and I'll prevent this from kind of spreading out and widening through use. So let's get this all set up and give this a cut. Now the thickness of this 1-inch tube is also the thickness of the wheel dolly that I cut up, so I want to learn from my mistakes. I don't have the right cutting nozzle, and it was just filling in behind me as I was cutting, so rather than do that with this, I've kind of got a little idea that I'm going to try out. So if I blow up on that thickness of the material, and this is 1/8 inch, when I go like this with my 0 cutting tip, it is not thick enough to do a clean cut, and it kind of welds back in behind me as I go. So this is 1/8 of an inch. However, if I go a pretty harsh angle, like 40-45 degrees, when I go to make that cut, I'm kind of making like a hypotenuse cut. So this thickness is going to thicken up on me. Plus, I'm going to blow in the direction that I'm cutting, and I'm going to give that a try and see how clean of a cut I can get. All right, so I've got my first piece set up here. I've got a couple of heavy plates to use as a guide, so I get a nice straight cut, a couple extra heavy plates just to kind of weigh it down, make sure things don't shift and move on me as I'm cutting. And this little piece is kind of small, so I've actually vice gripped it to the top of the table. Now, when you're doing most cutting, you've got it sitting off the edge of the table, and you can make a clean cut and the part falls off. However, in this situation, we don't want to cut through the whole thing. We just want to cut through the top surface. I definitely don't want to cut through the bottom, and I really don't want to cut through into my table. So I kind of have a little unique problem here. What can I do? Well, one of the things that we can do is this is a piece of aluminum. Now, aluminum and things that don't have any iron in it, like stainless steel, do not really cut well with a cutting torch because the cutting torch relies on that iron to rapidly oxidize and blow it out of the cut. But when you do that with aluminum, it actually makes something called aluminum oxide, which really doesn't burn well and burn at higher temperatures. So this kind of acts like a little guard. We can fit this right in between there. It'll protect my vice grip and the bottom surface of my cut. So we're going to give that a try. There we go. Aluminum's untouched. Awesome. And it looks like a pretty nice clean cut, so we're going to continue and cut all these up. Now, by no means is this indestructible. It's still getting melted. It's just not getting cut, and I have zero damage to the backside of my part, and my vice grips don't have a nick in them either, so yay, aluminum for the win. Okay, so now that we have these grooves all cut out and the vice grip handle is fitting in, I'm gonna take a flap disc and a grinder and kind of clean up that kind of flame cut edge, get rid of the slag inside with a file. That way these things go in nice and smooth. Now that we have these grooves all ground and everything fits nicely, it's time to figure out where we want to attach this to the main piece. So one of the things when you're doing this kind of stuff is things should look symmetrical. So what happens on the left should look the same as what's on the right. That's one kind of key thing. Second thing is when you've got spaces between parts, they've got to have some even spacing. So get yourself a tape measure, measure out, and in this case I kind of went one piece right at the end, the other piece at the other end, and space these equally so that I've got 6.5 inch distance between these. I think that looks good. I've marked them on the base here so I can transfer this over to the welding table, and we'll start welding that up. So to weld this up, use whatever welder you have, but for me I'm going to use a MIG welder today because it's quick and efficient and I want to just get this done. Now to hold the position of these brackets before I weld them in, I am using a pair of vice grips just to kind of clamp it in place, and get yourself a nice square so you can line everything up, make sure these are pointed straight out, and give it a couple tacks and make sure everything's in the right spot before you decide to fully weld them in. Remember, one of the big reasons for tack welding is making sure that everything is exactly where you want it, nothing's straight, nothing's crooked, everything's in the right place. In this case, we got this groove detail, make sure that they're all on the one side, and you have the opening on one side, right? Real easy to get these flipped around. Once you have this all tacked in and it looks great, well, go ahead and burn it all in for good. So now that I have this hanging up on our pegboard here, kind of just sitting on these pegboard hangers, the more I look at it, I kind of like the idea. If I was to take some of these pegboard hangers and weld them and incorporate them into the bracket, that way if I want to move this to another spot on the board here, it'd be really easy to just pull out and put in another spot. So I think I'm going to take some of these pegboard hangers, cut them down, weld them into the bracket, that way this thing just fits in and it's kind of movable. And honestly, if that doesn't work out and it starts to sag because there just is too much weight, it's not a big deal down the road to weld in a little flat bar bracket here or a piece of angle iron, drill a hole in it, and put in some concrete lag bolts, and then that'll be definitely strong enough. All right, so now that this is all made, a bit of a change of plans. This isn't heavy by itself, but once I start loading up a bunch of vice grips on here, there's quite a lot of weight, and it's really going to be tippy this way on this pegboard. So first problem is these pegboards aren't really going to be strong enough. And the second thing is I can't even screw down to anything solid because behind the pegboard is actually hollow. So there's nothing I can screw down without breaking this pegboard. So change of plans. I'm going to reorganize where stuff is here, and I have found a solid 2x4 supporting back right here. So we're going to put this here, and in order for that to mount, I'm going to make some nice strong brackets that we're going to cut up and weld on right now. Just a little hint, whenever you are putting or hanging something with multiple screw holes, if you put the one screw in and then you can position it and then line up and put your other hole in, rather than drilling 4, 5, 6 holes and then wondering why your screws won't line up. That looks awesome. All right, that's a wrap on another video from Weigh the Wrench and on how to become a welder. This very special episode was all about reusing and recycling scrap metal to be creative and make something cool, using some torch skills that we learned in the last video, and we even ate some humble pie. So remember, when you make mistakes, it's more important what you do with that new knowledge and how you are going to get better as a tradesperson. So if you have any questions or concerns about the video, just put them in the comment section down below and I will get back to you as soon as possible. And if you haven't already, why don't you follow us on Instagram, Weigh the Wrench. Until next time, take it easy.